Good morning all. Today I'm going to take a look at this. It's the PowerOak PS5B-UK Power Pack. And the UK bit is because the mains outlets on here have UK sockets. So what is this device? Well, it's a big box full of lithium-ion cells, 3 in series, possibly 10 or 12 in parallel. Here's a tin of lemonade. It's 330 millimeters as a size comparison. And this box has a display. I'll switch it on, press and hold that top button, which shows you how well charged the unit is. And there are 3 watt meters: input watts, DC output watts, and AC output watts. You probably can't see those very well at the moment. There's various output sockets. There's a 12 volt cigarette lighter output. There are two 2.5 millimeter 12 volt 3 amp outputs. There are 4 USB outputs of various flavors. There are, as I showed before, the mains outlets, 230-ish volts. And then there are a few, well, this is an output actually. It's an XT90, I think it is, probably connected directly to the battery in here and used to jump start a car. There's a Anderson power pole input here for a solar panel, and there's a DC input jack here for cigarette lighter charging from a vehicle or from the mains power pack supplied. Okay, let's have a look at the box it came in, which is here. And the first thing you'll see is 400 watt hours battery capacity. And on this side, you can see it being used as a jump starter for a car. There's various data here. We'll have a look at that in a moment. Here you can see a solar panel being used to charge this power pack. And there's a bit more information here, the accessories you get. And also on this unit, it's the 220 volt. It's actually a bit higher than that. I think it was 235 or something. Let's go back to the data on this side. Have a quick look at that. That's all the data provided. Let's have a look at the accessories provided. There's a mains power block here, which says 29.4 volts at 2 amps. There's also a UK cable there. There's a connector here which is MC4's to Anderson power pole. So this is for the solar panel input. There's a connector here for jump starting a car. I'm not going to do that. We've done that before on much smaller lithium power packs. We know it works perfectly well. There's a little protection device and the XT90 connector there. And there's also a cigarette adapter to power jack, and that's for charging this unit in a vehicle, and I might give that a try if I can. Now, this capacity figure, 400 watt hours, I just know one of the first questions in the comments is going to be, did you measure it? Is it really 400 watt hours? Yes, I did measure it, and no, it's not 400 watt hours. So let me explain how I measured it. 60 watt incandescent mains voltage light bulb, and this Energini power meter, which even when it's not connected to the mains has a little battery in it so that you can get accumulated milliamp hour, or no, milliwatt hour, no, kilowatt hour, or of course watt hour data. So this was my setup. Let's switch the unit on, press and hold that. Let's switch the AC on, press and hold that, and you'll see the light bulb fade up in brightness. And I simply ran this for something like 6 hours and discharged the unit fully. Then I fully charged it using the mains power pack supply. That took about 8 hours because, of course, because of losses, the charge time is longer than the discharge time. And then I fully discharged it into this lamp and got my final result. And the result was discharge 327 watt hours into the 60 watt bulb. And that's not surprising. In fact, there's even a section in the manual that explains why you won't get 400 watt hours. And the reason is because a cell's marked milliamp hour capacity, or you can convert that into watt hours, in fact it's here, 12.6 watt hours, is the total capacity of this cell, charged fully to 4.2 volts and then discharged fully to 0 volts. But you never discharge lithium cells to 0 volts, so you can't realise that full capacity of the cells inside this unit. I'm not saying they are 3400 milliamp hours in here, I don't know what they are. And the manual says here, there is 400 watt hour battery built inside. Now bear in mind, that is the marked capacity of the cells, and we don't fully discharge cells down to 0 volts. So there's a little equation here. Discharge capacity is nominal capacity, 400 watt hours, times depth of discharge, they've given that as 0.9, times the transfer efficiency, which would be of the mains inverter, they've given that as 0.86. They've said you'll get 309.6 watt hours. Now this is calculated at 300 watts of discharge. I only discharged this unit at 60 watts, so we did a little better than that. We got 327 watt hours, and that's entirely expected. I appear to be down to 2 bars on here. Now let me press that to bring the backlight on. Yeah, down to 2 bars. This is taking about 56 watts. This is bobbing around a little bit. Now, consequently, when I charged this unit, how many watt hours did it take at my main socket? 526 to charge this nominal 400 watt hour pack. Why did it take so much more than the nominal capacity? Well, because the power supply is inefficient. And in fact, this says 29.4 volts at 2 amps. That's about 60 watts, which is why I did my discharge at 60 watts. And the 29.4 volts, the 30 volts-ish, going into this unit is then further transformed down. There's probably another buck converter in here to get it down to the 12 volts-ish of the battery pack inside the unit. So let's turn off the AC output, press and hold the AC button, and that's off. Now you can probably tell from the very grainy image that it's a very dull overcast day today, so there's no hope of charging this with solar power. So I'm going to concentrate in this video on discharging this unit, and I thought it'd be quite fun to go with the manual's error codes. There's a whole bunch of error codes here. And it's really interesting, if you try to invoke these error codes, you learn a lot about how this unit works. So let's go through some of these and see what we can see. Okay, let's start here. E11, battery low voltage protection. Now this occurred when I fully discharged the unit using that 60 watt bulb. I think I've got a little clip of that. The lighting will be terrible, but here it is. Let's turn on the AC. That lights up. The indicator shows that a bit low, but I'm looking now for an error message. But I'm now just waiting for the lamp on the top to go off. Oh, it has gone off. And we've got an E11. Let's just light that back up again. E11, let's take a look in the manual. And E11 is battery low voltage protection. Charge it in time and restart it after it's fully charged. So E11 is the error message you get when the unit is fully discharged, obviously not to 0 volts. Now there are a number of error messages here talking about first battery string over voltage, second string, third string. So that's the 3 cells in series. And we've also got first string low voltage, low voltage, low voltage. And I don't think I'm going to be able to invoke these. The recommendation is just to disconnect the charger and restart it if it's gone over voltage on any one of the 3 strings. If it's gone under voltage on any one of the 3 strings, it just says charge the thing up. So let's turn our attention to the DC output. Now this is the 12 volt cigarette lighter output, and you can see that it's actually 13.1 volts. So clearly this cigarette lighter output is behind some sort of DC to DC converter, and I suspect it's a buck boost because at the moment the voltage on it is higher than the voltage of the cells. We're quite low here. We're probably down at about 11 volts. Now the other 12 volt output, there are 2 of them, they're both marked 3 amps, are a much lower voltage, and it looks to me like these coming directly from the battery, although they do go through a protection device, because I'm going to try and trigger that and get another of the error messages. So it looks like the cigarette lighter, 12.6 volts, it says in the manual, up to 10 amps, goes through a DC to DC converter. We were seeing 13.1 volts. These two sockets, which they say are used for 12 volt lighting, straight off the battery pack, 11.1 volts. Now look at this, a 12 volt car brake light bulb, 21 watts, so less than 2 amps. I'm going to plug that into the 3 amp output, and you can see that the voltage has immediately gone to 0, and we have an error message, E21. And E21 is 12 volt 6 amp output. There are two 3 amp sockets, overcurrent protection. But why did that output go into overcurrent protection when we can draw a total of 6 amps and yet my bulb is less than 2 amps? Well, it's because the filament is cold. So let's clear that error message by switching the DC off, switching the DC back on again, and you can see that the multimeter has gone to 11.1 volts. And now I'm going to connect this bulb to USB 5 volts. Now obviously it's not going to be very bright at 5 volts, but what it will do is it will preheat the filament. And now I'm going to connect it back to, that's the wrong end, the 12 volt output, but with the filament still warm. So let's disconnect it from 5 volts, connect it to 12 volts, and you can see that the unit's quite happy to drive this less than 2 amp bulb. In fact, we can see that we're drawing on the DC watt meter 19 watts. This is a 21 watt brake lamp bulb, but remember that in a car it's likely to be getting more like 14 volts than 10.6 volts. And yes, the unit's quite happy to do that, but these outputs have protection circuits which are very fast to respond, because it simply wouldn't give this bulb time enough to warm the filament before the protection circuit cut in. So they're very fast circuits. So the cigarette lighter output socket, the manual says 12.6 volts. I measured it at 13 volts. It says maximum 10 amps, that's 130 watts. If I plug in this heater, this in-car heater, which is 150 watts, 15 amps, are we going to get an error message? Let's find out. Let's plug it into the cigarette lighter output. Now it's got two settings, fan, which of course will be low current, and heat, which will be high current. And we can see from the display it's drawing 140 and it was climbing up beyond 140 watts, and we got an error message, E20. And E20 is the 12.6 volt, that's the cigarette lighter 10 amp output overload protection. So yeah, that detected an overload and it cut the output. Okay, this old extender, it's got a plug and 4 sockets, but it's got rather thin cable, so this is going to add a bit of resistance between the heater, which I'll plug into there, and the output of this unit. Let's cancel the error message by pressing and holding that. Switch this back on. The fan heater is on. There's a little more resistance in the circuit. That's climbing up. We've got 133 watts, 135 watts, and yeah, it's happy. This thing continues to run, and I'm getting hot air. My voltage is down to 10.8 volts. So a little bit of extra resistance in the circuit, and we don't trigger the overload protection. And this heater is still running, and the output is showing 138 watts, so we're slightly over spec. Oh, that has actually pinged out now, but it took a lot longer with this little extra bit of resistance in the circuit. Okay, let's turn our attention now to the USB outputs. There are 4 of them, and they're marked 2.1 amps, 1 amp, 2.1 amps, 1 amp. And these are a bit old school because the ones marked 1 amp, you can draw a lot more than 1 amp from them. In fact, let's give that a try. So this little unit is set to maximum. The pot is at its maximum setting. This will draw 3 amps. Let's see what the watt meter says. Oh, I need to shut off the DC because we've still got the error 20 message. Switch it back on. Let's plug it into the 1 amp output. And it's entirely happy. It's drawing 16 watts. So it's drawing 3 amps from the 1 amp output. Now these markings, 1 amp, 2.1 amps, this is just the resistors that they've got across the middle 2 pins. It's actually pretty meaningless these days. It says here that you can draw 5 volts. Let's see what the manual says about total current. Well, nothing helpful. It says 2 times 5 volt, 2.1 amps, and 2 times 5 volt, 1 amp. So what is it saying? We can take a total of 3.1 amps from each group. Well, let's give it a try. So this little power bank here says it's drawing 0.3 amps, but the voltage is very low at this end. That's probably because it's a terrible cable. But let's put this 3 amp load in as well on the 2.1 amp socket. And our total power consumption is 17 watts, and it seems to be holding. Let's get a bigger power bank. Okay, I've plugged a bigger power bank in here. Getting a pretty weird result, 1.75 amps, but the unit here is only saying 2 watts. Well, let's plug in my 3 amp USB load. That's taken it to 18 watts, and it seems to be happy with that. Okay, different cable for the power bank. That one with the display in it I think was pretty terrible. That's saying it's drawing 4 watts. Let's add in another 15 watts. And there we are. We've got an E23. So what are we saying? That getting on for about 20 watts, about 4 amps on the USB seems to trigger it. However, I think that 4 amp limit is for 1 pair of sockets. So let's clear the error. E23 that is. Switch the DC back on. Oh, it won't like that, will it? I think I pulled that out in time. If I put this on the other side, so that's my power bank charging on the other set of connectors, and put my 3 amps up here, it's going to be entirely happy to run that. We've got 21 watts. Let's see if we can go higher than that. Okay, my most rapacious power bank, this one can draw 2.4 amps. You can see that it's pulling 9 watts. Now if I add in this 15 watts, but on the other group of sockets, yes, we've pushed it up to 25 watts. Well, that's 5 amps at 5 volts. And as long as you spread the load over the 2 sets of sockets, it doesn't trigger the protection. But if I put this 3 amp load on that bottom group, it immediately triggers the protection, and we've got an E24, and I think E24 applies to one set of outputs and E23 to the other. And here they are, E23 USB number 1 output overcurrent protection, E24 USB 5 volt number 2 output overcurrent protection. Right, let's turn our attention now to the AC output, so I'll switch the DC output off. The AC output sockets are on this side, and to test this I've made up this very naughty cable, a mains plug to banana plugs. Switch the multimeter to AC volts and switch on the AC output, and we can see that that goes immediately to about 235 volts. Now the manual says pure sine wave 300 watts, peak output power 450 watts. Well, first things first, is it a pure sine wave? Well, let's find out. If I press and hold this button, it switches to graphing mode, and if I do the up and down buttons and I get it in the range of 50 Hertz, yes, that looks like a pure sine wave. certainly if you compare it with a modified sine wave. There's a little bit of data on the screen here, 233.8 volts, 0.049 kilohertz, which of course is 49 hertz. Not sure how accurate this thing is, of course. Would you like to see the output from a modified sine wave inverter? Well, here's a 150 watt 12 volt with a cigarette lighter plug, so I can plug it in there. Modified sine wave inverter. Let's take a look at the waveform from that. I'll switch on the DC output to get this modified sine wave inverter to come on. And there it is. And yes, you can see that a modified sine wave inverter produces basically a square wave, or a bipolar square wave. It goes first positive for a bit and then negative for a bit, but very clearly that's not a sine wave. So is that pure sine wave in any way affected by having a load on it? Let's put the 60 watt lamp on there. That comes on. And no, the sine wave looks pretty good even with a 60 watt load on it. Now, what about overload on the pure sine wave inverter? Well, here is an oil-filled radiator, and I don't know whether you can see the label there, but it says 400 to 500 watts, so nominally 450 watts. Now, that is the maximum overload rating for the AC output on this device. Let's see how it holds. Okay, let's switch on the AC output and we'll watch the power level. We'll also watch the sine wave. Oh, 459 watts. 458, 456, 459 watts. And we've got an error, and it's E13. And that is E13 inverter overload protection. Check if the AC output overloaded. Well, it says that overload is 450 watts. This is actually appearing to draw 460 watts. So yes, it would appear that the AC output is overloaded. In fact, it'd probably be more fun to watch the cell or battery pack voltage when this 450 watt oil-filled radiator comes on. So I've connected this to the DC output and switched that on. Let's switch on the AC output, see how long it'll hold. That's 460 watts. That's dropped to 10.3 volts and is falling quite rapidly. But the light is on the oil-filled radiator. Okay, we've got an error, E13. So the 450 watt oil-filled radiator runs for a few seconds, but this is a 320 watt dehumidifier. Let's try switching the AC on. And it runs very briefly, and then we get E14. What's that in the manual? Well, that one's slightly different. That one is inverter short circuit protection. Check if the output, AC output overloaded or short circuit. Now that's almost certainly because this dehumidifier, the fan is a low load, so it was quite happy with that. But the compressor is an inductive load, and I think the inductive load triggered the protection circuit on the power pack. So that was my first look at the PowerOak PS5B, and in particular its output capabilities, 12 volt, 5 volt and mains. I will take another look at this unit with regard to its inputs, particularly the solar input, but for that I need a sunny day. Today isn't a sunny day. So for the moment, cheerio.